Okay, good morning. In the last classes, we have gone through the various hydraulic circuits, like starting from control of single acting cylinder, control of double acting cylinder, then regenerative circuit, unloading valve application, counterbalance valve application, then meter in and meter out circuits. So all those circuits we have studied in the last classes. So there are few more circuits left out. We will go through all the remaining circuits. So today is the last class on hydraulic circuits. So by the end of today's class we will be completing the three modules. Okay, so today we'll concentrate on one more circuit. So this is again related to the speed control. So in the last classes we have gone through the meter in meter out circuit, that is related to the double acting cylinder. Control of cylinder used in pressure line, return line as well as in parallel line, that is bleed off circuit. So there we can control the extension by placing a flow control valve in the pressure line or in the return line. If the extension we need to control the input pressure, then it is called as meter in circuit. If the output line is metered, then it is called as meter out circuit. In both the cases, the extension is controlled. In the same way, instead of linear actuator, if you go for motor, that is rotary actuator, how the speed control is achieved? Again we know that the speed of a motor, that is rpm n, is directly proportional to the flow rate. If the flow rate is more, the rpm is more. If the flow rate is less, the rpm is less. Again the circuit diagram you can observe here is, so these are all the components of hydraulic power pack. So this is the component constituting hydraulic power pack. So here starts from the reservoir, filter, pump. We can connect one prime mover here, pump with prime mover, that is an electric motor. Then one pressure relief valve. So all these components constitutes together hydraulic power pack. Then we have a flow control valve here. If you observe keenly, you can observe one arrow mark is present. So this arrow mark presents, it is a pressure compensated flow control valve, and the reverse direction is free flow. So there is one check valve. Here we have a throttle. It is a variable one, and it is a pressure compensated. This is ISO representation. In NC representation, the arrow mark is written along with the line, and we have a check valve here. So check valve direction is like this. That means from the pump, the flow has to go through the flow control valve only. Whereas in the reverse direction, it will bypass this one. It is of least resistance here. The check valve will open up and it will made to flow back. So this is one directional flow control valve. Then as usual we have 4/3 direction control valve. At the center we have a unloading configuration at the center configuration. So these are the two working lines A and B. Now we observe the actuator we are connecting is bidirectional motor. So you can observe this triangle is pointing towards the center of the circle. Both the sides we have. That means it is a bidirectional motor. It can rotate either in clockwise or in anti-clockwise direction. If you supply the oil to the A port, then it may start rotating in clockwise direction, and when we change the direction to the B, it may rotate in anti-clockwise direction. That means A is clockwise direction, B is anti-clockwise direction. We get the rotation of the motor shaft in clockwise or anti-clockwise direction through which we are supplying the fluid. Now In first para, you have to say that all the components are arranged as per the circuit diagram. It represents only functional aspect. It is nothing to do with actual layout configurations. Now, at the center configuration, what happens when we start the system? Hydraulic oil is sucked and it is filtered through the pump. It passes through the check valve. Here itself, the metering of the hydraulic energy takes place. That is, flow is controlled. So this pump can deliver 100 lpm, but in this variable flow control valve, we can set it for 50 lpm, 30 lpm or 20 lpm based on our requirement. Based on that, the rpm can be controlled. So we can control the speed of an rotation of the motor shaft. So now let us consider the 50 set here. Only 50 liter per minute flow rate of oil is entering into the motor. Position A. When we operate this lever from left, so this configuration A will come into the center, then flow will enter from P port to A port, then it will go to the motor. Because of that, motor will start in clockwise direction. Once the motor is started rotating, whatever the oil present other side will come here from the outlet of the motor and it will go to the tank through B to T. So from B to T. So here in the left position, the flow will go like this, and here it will come like this to the tank. Now, when we change the position to the B envelope, when we change the position of the direction control valve to the B position, then observe what happens. From the pump through the pressure control valve, flow control valve, 50 liters per minute flow is coming, and it is from P to B is connected. So oil will enter the B port, then it will enter into the motor. Because of that, motor will start rotating in reverse direction. Let it be anti-clockwise direction. Once the shaft is rotated, the oil passes out, then it goes to the tank through A to T. So in this direction it will go. So here the rotation of the shaft can be controlled by varying the knob which is present on flow control valve. So here it is pressure compensated, whatever may be the load coming on this one, the RPM remains constant. Whatever the flow it is adjusted, it is pressure what is coming 100 RPM, it will constantly rotate at 100 RPM only, because we are using pressure compensated flow control valve. So this can be varied according to our applications by adjusting this knob. And we can see this a check valve is present. That means whatever the flow is generated from the pump, it has to pass through the flow control valve only, right? So this is a rotary actuator speed control. In the last class we have gone through the speed control of linear actuator. So that linear actuator, we have three types of configurations. One is meter in circuit, another one meter out circuit, another one bleed off circuit. So all those three are related to the linear actuator. So in the today's class we have discussed about the motor, the hydraulic motor. so which can rotate in either direction because it is a bidirectional motor. If you supply from one port, it will rotate in clockwise direction. If you supply an hydraulic fluid to the another port, it will start rotating in anti-clockwise direction or in the reverse direction. And the input which is going into the motor itself is metered here with the help of a flow control valve which is connected in series with the pressure line. So what is going into the motor, that line itself is controlled. So we can call this as meter in circuit because the inlet pressure is metered. So instead of this we can control the output also. So which is coming out of the motor can be controlled to have control over the rotation. Then also it is referred as meter out circuits. So here also you can have meter in and meter out circuits. The meaning is that meter in means the inlet line is metered. The meter out means the outlet line is metered, that is the flow control valve is present in at that position. So this is a speed control of motor, that is linear rotary actuator. Then one more circuit we have, that is locked cylinder with pilot control valves. So this is the circuit diagram. It is a locked cylinder applications. So in some applications we need to have the cylinder to be locked on that position. For example, if you consider one double acting cylinder, it is working under some pressure. So some load is coming on the cylinder. So in normal double acting control of double acting cylinder, what we don't have this setup. So these are the two pilot control valves. It is pilot operated check valves. If you omit this, how is the connection? So this we can connect to this one and this we can connect to the rod port. That is piston port and rod ports are connected. Then it is simply a control of double acting cylinder. So for the double acting cylinder circuit, what we doing is we are taking a pilot operated check valve. They have connected to the piston side and rod side of the cylinders in this way. Suppose during the extension we need to stop this piston at particular position, and whatever may be the load coming on that at that particular position, the cylinder should not move either in forward direction or in backward direction. That means depending upon the external load, it should not move from its position. It should be hydraulically locked at that position only. To achieve that, we will use two pilot operated check. Operated will check the flow in only one direction. The reverse direction is not possible. So this is a check valve, simple check valve. So here you can observe, so from left to right there is no flow condition, because it is checked by the ball of the chuck valve, no flow condition left to right. Whereas from right to left in this direction the flow is possible, because whatever the line we are supplying here, the pressure, it will pushes this ball out of this and flow exists through the valve. Now what happens? So this ball actuation is done by the pressure line itself, that is it is a direct acting chuck valve. Now what we do to move this ball, we are not using this main line. Instead of that we are considering one more separate line which pushes the ball, and the main flow will pass through this one. So this is a pilot operated chuck valve. So this pilot operated chuck valve is used in locked cylinder applications. You can observe how the pilot lines are connected here. So in this circuit diagram it is clearly visible that the pilot valve 1, you can call this as PV1 and PV2, that is pilot valve 1, and pilot valve 2. For better understanding, I will call this as PV1, pilot check valve 1, and this is pilot valve 2. So this is the pilot valve 2. For the pilot valve 1, so this is the pilot line where it is coming from. It is coming from the return line. So return line is the pilot line operation for PV1, whereas for the PV2, this pressure line is the pilot line for this one, right? When we shift the position, so in first para what we need to say, so that is all the components are arranged as per the circuit diagram. So this is the hydraulic power pack, which consists of reservoir, filter, pump with a prime mover. We can connect one prime mover here, then a relief valve which is used as a safety device, and now this is connected to the hydraulic system. So here we are using 4 by 3 direction control valve, and it is lever operated, spring centered. So when we operate the lever, unless and until it is in the operated actuated condition, it will be there in that position. When we leave the lever, automatically it will come to the center position, right? Now at the center configuration, all the ports are closed. When the system is on, the pump delivers the fluid, and it is hydraulically locked here. The back pressure is developed. By that, when it reaches the cracking pressure of the relief valve, the relief valve will open up and the excess flow will bypass to the tank. Now, when we change the position to A, so let us consider this as the position A. When it is come to the center configuration, what happens? Just observe. So from the pump, we have a flow direction like this. From P to A, it is connected, and from B to T, it is connected. That is, left envelope comes into the port positions. Now observe what happens. When the flow is here, the main flow will going here, and it will pushes this ball valve away from its seat. By that, the flow will pass through the valve. The pressure will pass through the valve, and it enters the piston, and pressure is applied on the piston. During that time, the cylinder will start extending. During that time, if you observe here, so here from this, one more pilot line is coming here. So this chuck valve will be moved up. So there is a passage for the fluid to pass through the chuck valve, because it is activated by the pressure line. So it will pass through the chuck valve, and it will go to the tank through the B to T connection. Here there is a pilot operation for this, that is PV2 is activated by the PV1 line. So PV1 will directly activate the ball, and it will pass through this one, and one more pilot line is coming here. It will move the ball out of its seat, so that whatever the oil is present here, it will go to the tank through this connection. So during extension, it work under normal condition as if there is no chuck valves. How it is working, in the same manner it will start works. Now when we cut off the supply intermediately, that means we are leaving the valve. So let us consider the piston is placed in the center position, at this position, neither in the fully retracted nor in the fully extended position. Suppose it is in the middle position now, because we have removed the actuation by hand. At that position, when the load is coming on this one, there is no flow here. So it is the center position now. All ports are closed. The pump pressure is going to the tank through relief valve. Now, when the load is coming on the cylinder at that position, what happens? So whatever the oil present here, this load will act on the pressure on the oil. So oil will try to move. If it is from this position, the piston oil will try to move out. And if the piston is pulled out, then what is the oil present in the rod side, that will try to move out of the cylinder. So in both the cases, now there is a presence of chuck valve. Because of the chuck valve, what happens? If the load is coming on the piston and it will try to retract, now the whatever the oil present in the piston side, it is locked here because there is a presence of chuck valve and there is no activating symbol for, that is pilot line for actuation of the chuck valve. The whatever the oil is here, it will try to come out but it is locked here because of the chuck valve. Now if we try to pull the cylinder, what happens? That is piston rod, whatever the oil present in the rod, it will try to come out and again it is locked here because there is a presence of chuck valve. Suppose if these two chuck valves are not present, then analyze what happens. So instead of chuck valve resistance, it will have a resistance at the DCV and it will cause some damages to the DCV as if the loads are very high. So because of that, to avoid the back pressure loading on the DCVs, we use chuck valves here. So chuck valve may be cheaper than, and it is cheaper than the direction control valves. So to avoid the damages on chuck valve, the direction control valves, we use a pilot operated connection. So without this pilot valves also, we can have a locked cylinder application when we use all the center configuration closed. When the load is coming on the cylinder, whether it is try to extend or try to retract, then the oil will come and resist at this blocked conditions. So it will cause some damages to the DCVs. To avoid that, we can have a pilot operated chuck valves to have a locked cylinder application. Now, when we change the position to the B, what happens? Just observe. Now we are supplied to the piston side. Now we will try to now we will change the position of DCV to the position B. Now what happens? Just observe. So this is the B position. When we change the position to B, the pressure line from the P is connected to the B port. So oil will come here through this direction. Then oil will enter here. Then it will push this pilot valve. The pressure line enters into the cylinder rod side. Then it will exert pressure on the rod side of the cylinder. During that time, one more branch is coming and it is activating the chuck valve here. During that time, whatever the oil present in the piston side, it will pass through the chuck valve because the valve is already activated and it will go to the tank through the port position PA to T. So this is the configuration here. So when we are shifting here, the retraction of the cylinder takes place under normal condition as it is done by the pressure itself, and the cylinder start retracting and the oil will pass through both the pilot operated chuck valves. Instantaneous time to and because of this chuck valve condition, the ball will be arresting the movement of the oil either from piston side or from the rod side. So because of any external load which is coming on the piston or the cylinder, it will not move the cylinder either in extension direction or in the retraction direction as they are hydraulically locked by the chuck valves. So this is the working principle of pilot operated chuck valve. So here you need to explain how the locking arrangement is done with the help of chuck valves. If these chuck valves are not present, the circuit is simply a control of double acting cylinder with all center position closed. Then also we can achieve the locked cylinder application, but the load coming on the DCV is more. To avoid that, we can use a chuck valves. So this is a pilot operated locked cylinder applications. And one more bit is remaining, that is accumulator circuits. While discussing on the accumulators, we have gone through the accumulator circuits. Once again, we will brief out it how the accumulators serve the purposes using the circuit diagrams. So we already studied that the accumulators can serve the four different applications. That is, one is auxiliary power source and the second one is emergency power source. Then it can be used as a shock absorber and also it can be used as the leakage compensators. So we will see the circuit diagram for each case. Now in the first one, it is used as an auxiliary power source, that is a secondary power source. So there is a one chakwal here, you can observe. So and this is the remaining part is your hydraulic power pack, and this is the graphic symbol for accumulator, and here we are using the cylinder which is a double acting cylinder controlled by a 4x2 direction control valve. There is no center configuration here. When we activate the valve, it will extend. When we release the valve, it will retract. So it is a binary valve, so it is depending upon the application of the lever. When the lever is operated, extension takes place. When the lever is released, it will retract. So this is the application. During some certain time, if there is any power failure in the system, now the cylinder is in the extended condition. Now we have to take back the cylinder, or in some applications the power failure occurs and whatever the energy stored here in the accumulator can be used for the extension and retraction of the valve, that is the cylinder. Now you can observe here, so this hydraulic power pack and the accumulator, they are connected in parallel connection. So this hydraulic system will receive the hydraulic energy from this line, from this portion. Here it will enter into the rod side in the unactuated condition. So here there is a presence of chuck valve. That means when we activate the accumulator pressure should go to the actuator only. It should not go to the pump side. So because of that we are using chuck valve. The load, whatever the energy which is stored in the accumulator should be utilized for the useful purpose of the actuator actuation only. So that we are using one chuck valve here to avoid the pressure on the hydraulic motor, sorry, pump. So this is an example of an accumulator can be used as an secondary power source. It is very simple. Connect one accumulator in parallel with the main power source, that itself is your auxiliary power source. Then another one is accumulator can be used an emergency power source. So observe here, in emergency power source, it is used in the return line. That is, in some emergency cases, let us assume that the cylinder is in the extended condition. So now we have to retract the cylinder even after the power failure also. So because of that condition, we are using one accumulator here. Now what happens? Now assume that the cylinder is in the extended position. Suddenly some power failure occurs and the cylinder remain in extended position because there is no supply from the pump and there is no actuation of the DCB. Now the cylinder is in the extended position. We need to take it back. Now the accumulator is already charged. Then accumulator is opened. The energy from the accumulator will enter into the rod side. Again we can see one chuck valve here. That means whatever the energy stored here, that has to enter the rod only. It should not go to any other positions. Now when you take out, when we tap the energy from accumulator, it will enter into the rod and takes the cylinder back to its initial fully retracted condition. operate here valve, or it can be an yes, it is a relief valve. So it will operate this relief valve and excess energy will go to the tank. So in case of emergency power failures, this accumulator can be used as a power source in case of emergencies to take back the cylinder from its position to the fully retracted condition. So after that, again, if the power comes, then the operation will be as usual. So during that time, the accumulator will get charged. Once it is fully charged, again the relief valve will operate and the excess will go to the tank. So that is when we change position to 1 and 0. So this extension and retraction will continue as usual. So here, in case of emergency failures, power failures, if it is in the extended condition, to take it back, we can use accumulator used as an emergency power source. That is one of the application. Then the third application is a shock absorber. So in a normal application of the hydraulic cylinder, the load is coming on the hydraulic cylinders. So in either side, we can have two accumulators. So whenever the shock loads are coming on this hydraulic cylinder, so during that shocks, the excess load, that is shock loads which is coming, it will direct into the accumulator. So we can have two accumulators here. One is in the pressure line, another one is the return line. So when the cylinder is in the extending position, during that time, if there is any shock load coming on that one, then that excess shock load is absorbed by the accumulator. The accumulator gets charged. That means that extra shock loads which are coming, that is fed into the accumulator and accumulator gets charged. During the retraction, if the shock loads are coming, then the shocks in the piston side will be absorbed by the A1 accumulator here. So during, if there is any shock loads, that excess shock load is absorbed by the accumulators here. So you can use this accumulator as a shock absorber. Otherwise, whatever the shock loads are coming, that will reflected into the pump itself directly. Then it may cause damage to the pump. To avoid that, we are using accumulators both in pressure line and return lines as a shock absorber. The circuit diagrams are very simple. Just write two accumulators in both the lines, that is in pressure line as well as in return line. So then it will serve the purpose of shock absorber. And one is leakage. This one, but whenever there is a leakage in the pressure line, it will be sensed by the pressure switch here. There will be one pressure switch, that is to measure the fluid pressure. So whenever there is a leakage, there may be a pressure drop occurs. So when the pressure drop occurs, the particular pressure is not met. So that decrease in the pressure is sensed by the pressure switch. When it pressure switch is activated, the valve will, that is accumulator, will open up and it will supply that excess pressure. So here the accumulator should be charged first before it is used as a leakage compensator. Whenever the pressure drop occurs, it will sense that there is some leakage in the hydraulic fluid. To compensate that leaked oil, the same amount of oil comes out of the accumulator which is already charged. That means it is already charged. So whenever there is a leakage, so it will supply the fluid to the line to compensate that leakage. So here, along with the accumulator, we have to write one pressure switch here in parallel with the main supply line. So this will serve the purpose of a leakage compensator. So we have studied the four different types of accumulator circuits. One is the leakage compensator, second one is the shock absorber, and the third one is emergency power source, and the last one is auxiliary power source. So these are the four types of hydraulic circuit applications with accumulators. So this will finish your module 3. All the circuits we have completed. If you have any doubt, you can ask related to this hydraulic systems and circuits. Do you have any doubts? Nagraj and Suresh,
No,
only
sir.
two are present.
Yes.
What about others?